So let's create zones out of this. Let's see, I had here. Yeah, I'm gonna do a couple more steps with UI controls, and then we'll switch to data file. So we created these zones. Let's assign groups to the sides of this model, so we can easily say apply roller boundary conditions on right and left side and fix the bottom boundary. Instead of identifying it by coordinates, we're just gonna call left boundary west, east bound, right boundary east, bottom boundary south, top boundary north. It's actually coming from 3D, where it's hard to identify what is right, what is left. So we use the same concept here. So for that, we're gonna click here, assign group names to faces automatically. It will correspond to command zone skin by face, or sorry, zone face skin. Essentially, it's going to issue that command. But if you click on this A button here, and you can say ignore existing group names. Or actually, let's not ignore it. Just press assign groups. Doesn't matter. We will see that our domain kind of got split in the boundaries only. And what we got here on the right side, you can see there's like block 2, block 2, block 2, and then non-tunnel. So you see this block 2 and none. Those are groups coming from initial construction, because we already assigned tunnel group. And when we created zones, our sketch also put them in so-called construction layer or construction slot and assigned to each block names like block 2, block 1, and so on. So let's first see, like in construction slot, there's nothing, but in default slot, sorry, in skin slot, we have these multiple groups. We actually don't care about this right now. It may be a bit complicated. What we care is that we have separate group names for each side. So other things that you could do from model pane, let's say we want to create structural elements around the circumference of the tunnel, like a liner. We can select this circumference and go here and say create structural element. It will create geometry for structural element, but will not assign properties. We are not going to do that right now. This is actually, here we stop, and we're going to say zone save geometry. That's all we need for this simple example for geometry. So when you got to this point, just type in command line zone save, sorry, not zone, model save geometry. I'm sorry. Model save geometry. Also, you notice that we switched to the showing boundaries of the models or zone faces. We can switch back by clicking here in model pane to see zones. We basically can switch between what's the boundaries or faces on the boundaries and the original model. So this is what's available in model pane. Previously, if you remember, we assigned material properties in constitutive models in the previous example by basically selecting this and going here and saying assign constitutive model or assign material properties. You can actually predefine material properties in a database and directly pull them in this database. But right now it's empty for me. I didn't define any material property. I think if you're interested how to do that, I think there's some information in the documentation, but this is kind of outside the topic of this example. So let's go back to data file now. So we created geometry, saved it in model state geometry. Now we're pretty much done with this first step. We can always restart the model just by invoking that geometry back again. That's why we're restoring it here. We're setting large strain here. And now we need to assign constitutive model. So here, start typing zone C model. We're going to use more Coulomb. That's the same thing that we could do from model pane. Then we need to provide properties. The typical properties, we type zone property. Typical properties are density. Let's see what's density. Let me just here. Okay. And density. Have density 2000. We have bulk modulus. 1 is 7. Have shear modulus 2 is 6. Then we can type 3 dots. I forgot what the syntax term for it. Ellipsis, I think. And that means that my line continues and I can go to the next line. Then I can type cohesion, 5, friction. Friction, it's friction angle, and then tension, it's tensile strength. These are the parameters of my more Coulomb model. That's basically all I need for constitutive models and properties right now. Next, boundary conditions. Yep. Oh, yeah. Zone property, of course. I forgot there's a keyword assign. Or you're right, zone C model. Wait, is that right? Let me see. You're right, assign is here, zone C model. Yeah. Now, boundary conditions. We want to have grid point fixed on the boundaries. So there are different ways how to do it. We can say zone face apply velocity. So we're applying some velocity boundary condition. I think it's velocity normal. Yeah. Velocity. So we're applying velocity normal orientation to the boundary. And it's 0. Essentially, we're fixing it. 0. Type ellipsis. Range. Loop. West. Let's look what I typed here. We have the side boundaries. Each of them, one is east, one is west. We're fixing velocity in normal direction, meaning that the boundary cannot move in normal direction, but it can move vertically. I mean, normal direction to vertical boundaries is horizontal direction. Another way to do it would be zone grid point fix velocity x. The same thing. We're basically fixing it in horizontal direction, but allowing these boundaries to move vertically. This is essentially roller boundary conditions. And then on the bottom, it's fully fixed. We're gonna do the same zone, face, fly, velocity, just say 0. Range, loop, bottom. So that's what you should get. On the bottom, we're fixing velocity completely. That means material cannot move. Finally, initial conditions. We need to set gravity, model gravity. And notice that I'm not saying zone gravity, I'm saying model gravity, because gravity applies to model 9.81. And gravity is by default assumed to be acting downwards. You can actually change gravity vector if you specify it, for example, like this. This gravity vector will be acting upwards. But if I just say one value, it's going to be downwards. You can set gravity horizontal if you want. And we also need to initialize stresses. There's this command zone stress initialize. Is to set up initial stresses with K factor, 0.7 K factor. You remember it's ratio of horizontal stresses to vertical. And we can set them separately in both horizontal directions. Specify a single number, we will setting them the same. So it's horizontal stress are 0.7 times of vertical stress. This is my initial conditions. Stress will change later. Histories to track. Let me actually switch to the next slide to see exactly the points where I track history. First, we're gonna track unbalanced force model. We're gonna say model history. And the way to track unbalanced force is this a bit complicated thing, but basically we're tracking mechanical parameters, and among them we're gonna track how the unbalanced force changes. That's what we're saying. Basically, history of mechanical unbalanced force. And then we're also gonna track vertical position of the point at the tip of the tunnel or the top portion of the tunnel. So we're gonna say zone. So now this is zone level parameters. It's not for the whole model. Only something that's relevant for zones. So zone history, displacement. We're gonna track vertical displacement, so it's Y. At the position, if you remember, the tunnel was 14 meters in radius. So we can say position. We can specify vector like this 014. Or we can just say 0-14. Sorry, 0 space. Finally, we need to solve to initial equilibrium. So we're going to say model, solve, and if you remember convergence, we can just say solve, or we can say convergence 1. For this simple model, it doesn't really matter. For complex models with various with different entities like structural elements and different materials, probably using convergence is better. So we'll just say model solve. Let's try to run it and see what we got. Let me also create number of plots right away, so we're able to see how things change. I'm gonna say file new plot, and let's say stresses. We're gonna track vertical stress. I'm gonna add your zone, and remember from this plus sign, I'm adding different plots, and few shortcuts are already here, like histories and zones. And then from here, I'm gonna say contour, and let's say vertical stress, and stress YY. Right now it's empty, but I'm gonna remake them. I can make them afterwards, doesn't matter. Let's first see how the stress, at least vertical stress, change, because this is simple model. We haven't excavated anything under gravity. We should have linear gradient of vertical stress. So I'm gonna open that data file again and run it. Basically, you see that we created geometry. Then we're gonna restore it. We assigned material properties, boundary conditions, initial conditions. set which histories we want to track, and now we're ready to create initial solution. Oh, that's actually my mistake. Sorry, I have a mistake here. So when we apply zone face apply velocity, we need to specify vector of two components of velocity, x and y. I think this should work, so let me try to run it. And here I think also my mistake, initialize stresses. Or initialize stress. That's 7. Sorry. Ratio, yeah. I didn't fix something. Obviously, the model completely failed. Let me check. So this is where we're gonna troubleshoot. Let me restore. So one of the simple way how to troubleshoot is we're gonna put return statement here and just run geometry. This first 3 lines. This is my initial geometry. Let me see which faces I have. I'm gonna create another plot item. I'm gonna hide this one. You see, if you click on it on circle, I'm gonna hide this one. And I'm gonna plot faces. It essentially will show me the boundaries of the model. Yeah, so remember that checkbox that I had, ignore existing group names. That's what messed up things. Basically, existing group names were not ignored, and they got included in the current group name. They basically need to specify block to bottom, block to east, block to west, with space in between. Would be like this. Later, you can reopen this from solution folder, and over there should be all right. Let's try to see if this one runs. Yeah, this one runs. I just had 1 group names. By default, when you create geometry, Sketch assigns default group names to every block. Block 1, block 2, block 3. When I didn't select that button, checkbox, ignore existing names, when I was assigning new groups, they got kind of added. New group names got added to existing group names. So this is something that I have now. I can turn off this plot, zone faces, and go back to zone groups, and back to contours plot and see stresses. And also I'm gonna use average method to see that it's linear variation, vertical stresses. So after this, I want to save the model. So I'm gonna add here model save initial. And here's one useful trick for you to know. Data file. So if you click on the line number, it will select that line. Now there is a button here on the menu. You see this document with a green dot. If I click on this button with green dot, it will only execute that line. It will not execute the whole data file. So if I click on it, it's actually only going to save my model. I could type this command here in the console as well. Or I can rerun the whole model and it will save it. This is really small model. It's really fast to rerun. So that's my initial state. you should get something like this. Make sure that you get similar magnitude here. If you're way off, that means you probably typed some properties incorrectly. Another way, or another thing you can plot here, boundary conditions on this plot. Let's say where we fixed our grid points for our faces. So if I click on this plus sign, there's a number of different plots, and I can have GP fixity plot. I can change colors. If I go here on the right to color list, and change, let's say, this blue color to, I don't know, to black. Increase line thickness so you can see this one. Red. So I can see that on my left and right sides, I fixed grid points in horizontal direction, and on the bottom, it's fixed both in horizontal and vertical direction. That's actually what I want. So that's why the model works fine now. Previously, nothing was fixed, and we could see the whole model failing and translating, and you have to fix something to prevent rigid body motion and rotation. So you can see that there's plenty of plots you can plot here. Most typical that we plot is zone, GP fixity, sometimes phase when we need to troubleshoot something. For example, attach conditions, boundary of the domain, and also histories for how things evolve in time. And then there's a lot of additional plots that, well, right now we're not going to use them. If you have PFC license, you can couple this code with completely discontinuous code, PFC, and then you can plot PFC items as well. But by default, they are. Right. Turn this on, you see how many new plots appear here.